Welcome to Project Bazaar. Let me discuss about the project Image Restoration using Joint Statistical Modeling in a Space Transform Domain. Let me discuss about the abstract of the process. Analyzing images to estimate the underlying parameters that lead to their formation is fundamentally an inverse problem, since the observed image alone is usually not enough to uniquely determine these parameters. Statistical models are frequently used to choose a likely solution from amongst those that are consistent with this observation. In this dissertation, we use such a statistical approach to develop image models and corresponding inference algorithm for two vision application, and then explore image statistics in new domain. A giant statistical modeling in an adaptive hybrid space transform domain is reputable. It offers a powerful machinery of combining local smoothness and non-local self-similarity instantaneously to ensure a more reliable and robust assessment. A new form of minimization purposeful for solving the image inverse problem is verbalized using JSM under a regularization based agenda. It is worth noticing that this displacement field is also used to introduce a bicubic upsampled image as an initialization. The attained high determination gradient is then regarded as a gradient check or an edge preserving constraint to recreate the high resolution image. The smooth edge familiarity is a smoothness restriction. Gradient magnitudes of JPP edge directed are less stringent than those attained through our scheme and the soft cut technique. The nature of the image inverse problem: prior knowledge about natural images is usually employed, namely image property, which essentially play a key role in achieving high quality images. Here two types of popular image properties are considered, namely local smoothness and non-local self-similarity, is illustrated by image Lena. The former type describes the piecewise smoothness within local region as shown by circular region, while the later one depicts the repetitiveness of the textures or structures in globally positioned image patches as shown by block regions with the same color. Let me discuss about the flow diagram for our process. First, capture the input image from source file by using getFile and image function. User can able to change the size of the image by providing pixel height and width with the help of imresize function. Select blur image with a specified blur type by choosing filter type with the help of special and imfilter function. Next, in the deblurring process, after perform the deblurring operation, need to do the deblurring by applying JSM algorithm, a JSM for high fidelity of image restoration in an adaptive hybrid space transform domain. Specifically, JSM is established by merging two complementary models: local statistical modeling, that is LSM, in two-dimensional space domain, and non-local statistical modeling, that is NLSM, in three-dimensional transform domain, which control the trade-off between two competing statistical terms. LSM corresponds to the above local smoothness prior and keeps image local consistency, suppressing noise effectively, while NLSM corresponds to the above non-local self-similarity prior and maintains image non-local consistency, retaining the sharpness and edges effectually. Digital images are subject to deblurring due to many hardware limitations such as atmospheric disturbance, device noise, and the poor focus quality. In order to reveal the detailed information carried in the digital image deblurring or restoration is necessary. Through simulation, one have realized that even with the prior knowledge with the degradation of function and noise model, the quality of image restoration varies, which is dependent on the choices of threshold value alpha. To deblur the image, we need a mathematical description of how it was blurred. Next, in the text removal process, deblurred results are given to the inpainting process as input, then apply paint on the input image. The inpainting process is performed. It is a process of reconstructing lost or deteriorated parts of images in the digital world. Inpainting refers to the application of sophisticated algorithm to replace lost or corrupted parts in the image data. The goals and application of inpainting are numerous, from the restoration of damaged image to removal of specified objects. Here we use JSM algorithm to perform inpainting in the process. The inpainting domain and is where the original image has been damaged due to age action, or also the region that we desire to add or remove information. The fillingness of missing information And the removal of noise are two very important topics in image processing with several applications such as image coding and wireless image transmission. Next, in the mixed noise removal process, in-painting results are given to the mixed noise removal process as input. This image is corrupted by both Gaussian or salt and pepper noise mainly. One goal in image restoration is to remove the noise from image in such a way that the original image is discernible. The sources of noise in digital image arise during image acquisition and transmission. There are many different noise such as Gaussian, Rayleigh, exponential, uniform and impulse. In our project, salt and pepper noise removal with a fixed value of impulse ratio. The basic idea of mixed noise removal is to fill in region with available information from their surroundings. In most cases, the available data of the original image is noisy, which makes it necessary to eliminate the noise and fill in the blank spaces, those without information. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right click that file and run for executing this process. This is the main window for the deblurring process for the JSM. And this is the input image button. You can browse the input image from the dataset folder. Select any one image from the dataset folder. I display that input image in the axis 1 plot. Now you can change the pixel height and the pixel width. Now resize the input image with mention the dimensions. This is the resized image displayed in the axis 2 plot. Now by pressing the next button you can go to the next window. This is the deblurred image window. Here by pressing the deblurring image button you can perform the deblurring process. Here I mentioned the iteration level as 3. So this process will be repeated for 3 times. We display the PSNR level and also display every iteration PSNR level. And final PSNR we obtained. This is the blurred image and here I displayed the deblurred image. This is the PSNR representation for deblurring process. Now by pressing the next button we can move to the in-painting process. This is the in-painting window. Here I add the mask for the painting. Select any one images for painter and by pressing the in-painting image button we can perform the in-painting process. Here also I use the iteration level as 3. So this process will be repeated for 3 times. Here also I display the PSNR for every iteration and we got the final. Here I display the painted image and here I displayed the in-painting image with the PSNR. This is the PSNR representation for in-painting process. Now by pressing the next button we can move on to the mixed noise removal process. This is the mixed noise removal window. Here by pressing the mixed noise image button we can perform the mixed noise process using JSM. Here also I mentioned the iteration level as 3. So this process will be repeated for 3 times. Here I display the PSNR level for every iteration. Finally we got the mixed noise result. This is here I display the mixed noise image and here I display the noise removal image with the PSNR. This is the final PSNR representation. Finally, image in painting, deblurring and mixed Gaussian and salt pepper noise exclusion have shown that the proposed algorithm achieves substantial performance expansion. Thank you.